Somewhere in the dark between galaxies, you see a cloud of gas starting to collapse. No star burns inside it yet. No planet moves around it. No light breaks through the dust. Only gravity works in silence. The cloud falls inward. Slowly at first, then harder. The center grows dense. The outer gas follows. 1 million invisible particles drift toward the same grave. Then the fall changes. The cloud starts to turn. A tiny sideways motion becomes a slow rotation. The slow rotation becomes a disk. The disk begins to heat. Gas spirals inward. Dust collides. Pressure rises. And somewhere inside the violence, a star begins to form. You might expect gravity to pull everything straight down, as if the universe were only a giant sinkhole. But space rarely allows a perfect fall. Matter almost always carries a sideways motion. A small drift here, a slight angle there. A memory of some earlier pull. And once matter begins to collapse, that tiny motion becomes dangerous. The rule behind it is called conservation of angular momentum. The equation can be written simply. L equals I times omega. L is angular momentum. I is moment of inertia, or how spread out the mass is. Omega is how fast the object spins. When a collapsing object shrinks, I get smaller. If L is conserved, omega has to rise. The spin gets faster. A figure skater proves the same law on ice. Arms stretched out. Slow rotation. Arms pulled inward. Sudden acceleration. Nothing magical happens. The mass moves closer to the center, so the spin tightens. Now replace the skater with a cloud wider than a solar system. Replace the ice with empty space. Replace seconds with millions of years. Gravity pulls the cloud inward. The cloud shrinks. The spin accelerates. And the universe begins building a machine. Rotation feels harmless from Earth. A day passes. The sun rises. The sky darkens. The ground appears still because everything nearby shares the same motion. But across the universe, rotation is far from harmless. It is one of the reasons matter does not simply fall into itself. It is also one of the reasons matter becomes violent enough to feed black holes, expose invisible mass, and twist the shape of spacetime. The terrifying part is not that the universe spins, but what the spin is doing. It is holding reality in a narrow balance. Too little rotation, matter collapses too directly. Too much rotation, It tears itself apart. Everything familiar exists between those two disasters: planets, stars, galaxies. Even the quiet ground under your feet, all of it sits inside a compromise between falling inward and flying away. The earliest structures in the universe did not begin as perfect objects. They began as irregularities, small regions where matter was slightly denser than the space around them. Gravity favored those regions. They pulled in more matter. The pull grew stronger. Gas collected. The first great clouds formed. But those clouds were not perfectly still. Nearby clumps tugged on them. Matter flowed unevenly. Gravity added tiny torques, little twisting pulls across enormous distances. A cloud did not need a giant cosmic hand to spin it. A small imbalance was enough. Once collapse began, the imbalance had nowhere to disappear. Space offers almost no friction compared with a floor, a table, or air. A top on a desk slows down because the desk steals motion from it. A spinning wheel loses speed because bearings heat, air drags, and surfaces resist. In deep space, motion can survive for ages. A gas cloud can preserve the memory of its first turn. Then gravity compresses that memory until the motion becomes impossible to ignore. The cloud flattens. A disk appears. People often picture space as a place where objects simply float. But many of the most important structures in astronomy are disks. Protoplanetary disks around young stars. Accretion disks around black holes. Rotating disks of stars in spiral galaxies. Disks form because rotation changes the way collapse works. Gas can fall inward along the axis of rotation more easily. In the rotating plane, sideways motion resists the fall. Matter spreads out. It gathers into a rotating sheet, a cosmic blade, a nursery, a feeding system. The same shape can build a planet or feed a monster. Around a young star, the disk becomes a construction zone. Dust grains collide. Some break apart, some stick. Larger grains form, then pebbles, then boulders, then planetesimals, then worlds. A planet is born because dust avoids falling straight into the central fire. The disk buys time. It creates repeated collisions. It gives gravity something to work with. Without the disk, matter would have fewer chances to sort, gather, and grow. With the disk, chaos becomes organized violence. If you could hover far above the newborn solar system, you would not see peace. You would see a rotating storm, the young sun burning at the center, gas streaming inward, dust heating and cooling, chunks colliding in the dark. Some material falls into the star, some escape. Some survive long enough to become planets. Earth began inside that rotating debris. A small body growing inside a disk that existed because gravity failed to make everything fall straight. Rotation helped save the material that became Earth. But the universe uses the same process for darker work. Move the same idea away from a newborn star. Place it around a black hole. Gas still spirals. Matter still heats. The disk still controls the fall. But the destination has changed. At the center now sits an event horizon. A boundary where escape becomes impossible. Around a black hole, matter does not fall quietly. It winds inward. It collides with itself. It heats to extreme temperatures. It can glow in X-rays. A feeding black hole can outshine the galaxy around it, not because the black hole itself shines, but because matter dies loudly before crossing the edge. Rotation turns the black hole into an engine. Without angular momentum, gas would plunge more directly. With angular momentum, it forms a disk. The disk becomes hot. This hot disk then radiates. Magnetic fields twist through the plasma. Jets can launch from the region around the black hole, firing matter outward across distances larger than entire galaxies. A strange cruelty appears in the design. The same kind of rotating disk that once helped build Earth can become the bright throat of a black hole. The universe does not use separate machinery for creation and destruction. It uses the same machine under different conditions. A disk around a young star can make worlds. A disk around a black hole can mark the last visible moment before matter disappears. Rotation delays the fall. Sometimes that delay creates a planet. Sometimes it creates a scream of radiation before the end. The same rule becomes even stranger at the scale of galaxies. A galaxy looks like a slow thing, a calm spiral. A pale island of stars. But the stars inside it are moving at enormous speeds. The Sun orbits the center of the Milky Way at roughly 230 kilometers per second. One full trip takes about 200 million years. Dinosaurs could rise and vanish, while the Sun completes only part of a galactic circuit. At the outer edges of spiral galaxies, stars move in a way that created one of the largest problems in modern astronomy. They orbit too fast. The visible matter does not seem heavy enough to hold them. Stars, gas, and dust can be counted. Their gravity can be estimated. The math says the outer stars should behave differently. They should slow down more with distance from the center. Many do not. They move as if the galaxy contains far more mass than telescopes can see. The stars are moving as if the dark has weight. Astronomers call the missing mass dark matter. The name sounds like a substance already understood. The truth is colder. Dark matter is inferred because gravity gives it away. It bends light. It shapes galaxy clusters. It affects how galaxies rotate. It seems to outweigh the ordinary matter that forms stars, planets, dust, and bodies. Rotation becomes the clue. A galaxy turns, and the turning motion betrays the invisible structure around it. The bright disk may be only the visible part of a much larger gravitational system. The Milky Way may sit inside an enormous dark halo, a hidden mass surrounding the stars like an unseen ocean. You can imagine a dancer moving in a dark room. Only the hands glow. The hands move in wide circles. From the motion alone, you know the body is there. Galaxies do something similar. The visible stars move. The dark mass never shows its face. But its gravity grips the dance. The universe is spinning, and the spin reveals that visible matter is not in full control. The luminous universe may be the smaller part of the machinery. Stars look dominant because stars shine. But light is not the same as mass. The galaxy rotates inside something larger, darker, and still unidentified. The edge of the Milky Way is not a clean border. It may fade into a halo of invisible gravity. A region where ordinary eyes see emptiness, while the motion of stars says otherwise. The universe is not only turning, it is turning inside a darkness that weighs something. Then, rotation reaches the dead. A massive star spends its life in a struggle between pressure and gravity. Fusion in the core pushes outward. Gravity presses inward. For millions of years, the balance holds. Then the fuel runs low. The core can no longer support itself. Gravity wins. The star collapses. The outer layers explode into space. The core is crushed into something smaller and far more dangerous. A neutron star can pack more mass than the Sun into a sphere roughly the size of a city. Matter reaches densities that make ordinary objects seem like smoke. A teaspoon of neutron star material would weigh billions of tons. The star is dead, but its rotation survives. And survival becomes acceleration. The original star had angular momentum. After collapse, the core becomes tiny compared with what it once was. I drops. Omega rises. L equals I times. Omega becomes a death sentence. The smaller corpse spins faster. Some neutron stars rotate many times per second. Some older recycled pulsars spin hundreds of times per second. Imagine a city-sized object turning faster than a kitchen blender. Now, give it the mass of the sun. Give it a magnetic field strong enough to tear atoms apart. Give it beams of radiation sweeping through space. A pulsar is born. The beams pass across Earth like a lighthouse, producing pulses so regular they can act like clocks. A dead star becomes a metronome. A corpse ticking in the dark. If you were near one, the word star would feel misleading. A normal star warms. A neutron star punishes. Its gravity is immense. Its surface is crushed beyond anything familiar. Its magnetic field can dominate the space around it. Its rotation turns death into a signal. A pulsar does not need flames to terrify. Precision is enough. A clock made from collapsed matter, spinning with a rhythm that outlives civilizations. Rotation did not vanish when the star died. Gravity compressed it. The motion became faster, harder, more concentrated. The same law that makes a skater spin faster on ice also turns a stellar corpse into one of the most precise objects in the sky. Makes the universe feel less comfortable. The laws are simple enough to write on a page. The results can be monstrous. Angular momentum does not care whether the object is alive, dead, forming, or falling. It only keeps the account. Collapse inward, spin faster, shrink again, spin harder. The rule follows matter into places where matter almost stops being matter. And around black holes, rotation goes one step further. A black hole can spin. The simplest black hole has mass and gravity. A rotating black hole has something more. Angular momentum. The space around it changes. According to general relativity, mass curves spacetime. A rotating mass can also drag spacetime around with it. The effect is called frame dragging. Near Earth, frame dragging is tiny, measurable only with extreme precision. Near a spinning black hole, the idea becomes far darker. Space itself is pulled into the turn. A nearby object cannot treat the region as ordinary emptiness. Paths twist, orbits shift, falling matter spirals. A disk can wobble because the black hole is dragging the local frame of spacetime around it. That wobble is called lens-Thirring precession. A spinning mass does not only curve spacetime with gravity, it also twists the nearby geometry, and it forces orbiting material to slowly shift its angle as it moves. The analogy is thick honey in a cup. Place a spoon in the honey. Turn it. The honey near the spoon starts to move. keep turning, and the motion spreads outward. Near a spinning black hole, space-time plays the role of the honey. The black hole turns. The surrounding geometry is forced to respond. At that point, rotation has stopped being ordinary motion through space. It becomes motion imposed on space. A spinning black hole does not merely sit inside the universe. It twists the stage where the universe performs in a scary way. Rotation begins as a tiny sideways drift in a cloud of gas. It builds disks, it forms stars, it helps planets survive. Then the same conserved motion appears around black holes, neutron stars, and galaxies. At the limit, spin reaches into the structure of space-time. A familiar motion becomes a relativistic weapon. You can spin a coin on a table and watch the same kind of principle in a harmless form. The coin leans, it precesses, it slows, it falls. But remove the table, remove the air, increase the mass until gravity bends light. Compress the object until atoms collapse. Then the same family of ideas becomes cosmic. The math stays clean. The universe does not. There is another equation worth knowing. Rotational kinetic energy is 1/2 times I times omega squared. Energy equals 1/2 I omega squared. Double the spin rate, and the rotational energy rises by 4. Push rotation to extreme speeds, and the stored energy becomes enormous. A young star can store rotational energy. A disk can convert orbital motion into heat. A neutron star can carry enough rotational energy to power radiation for thousands or millions of years. A black hole's spin may help drive jets through magnetic fields and surrounding plasma. Rotation is not just motion. It is stored violence. Most of the time, the violence is controlled. A planet rotates slowly enough to keep its shape. A moon orbits without falling. A solar system remains stable long enough for life to appear. But control has limits. Too much spin can tear an object apart. A star rotating near its breakup speed can shed material from its equator. A planet can bulge. A disk can become unstable. A neutron star spinning beyond its allowed limit would fail to hold itself together. The universe permits rotation only up to the point where gravity can still keep the object from flying apart. What's terrifying is the balance. The universe is not stable because nothing dangerous is happening. It is stable because dangerous forces are caught in temporary agreements. Gravity pulls inward, rotation pushes sideways, pressure pushes outward. Magnetism channels plasma. Radiation fights in falling matter. Every stable system is a negotiation. Every orbit is a fall that keeps missing. Earth is a good example because it feels safe. It rotates once every day. The motion gives the planet its day-night rhythm. It helps shape winds and ocean currents through the Coriolis effect. It gives life a clock. But Earth also carries a deeper motion inside. Beneath the crust and mantle, the outer core is liquid metal, mostly iron and nickel. Hot, dense, moving. The motion of electrically conducting fluid helps generate Earth's magnetic field through the geodynamo. Rotation helps organize those flows. The result is a magnetic shield extending into space. The Sun constantly throws charged particles outward as solar wind. Earth's magnetic field pushes back. It guides many of those particles around the planet. It helps protect the atmosphere from long-term erosion. It helps shield the surface from some of the violence of space. The blue planet survives under an invisible defense system. Not a wall, not a shell. A moving magnetic structure born from heat, metal, rotation, and flow. The same universe that makes pulsars and black holes also gives Earth a quieter version of rotational machinery. A version stable enough for oceans, clouds, skin, breath. If Earth's rotation changed radically, the planet would change with it. Days would stretch or shrink. Weather systems would reorganize. The balance between heat and motion would shift. The magnetic field depends on interior motion, and a dead core would leave the planet more exposed. Mars carries a warning in its silence. It once had a stronger magnetic field. Today, its global shield is gone. Its atmosphere is thin. Its surface is cold, dry, and exposed. Earth remains alive partly because its interior has not gone quiet. The ground feels solid. The planet is still working beneath it. You are standing on a rotating world with a molten engine below and a star throwing charged particles from above. Safety is the illusion created by scale. From a human lifetime, Earth seems steady. From cosmic time, Earth is a moving system holding back damage. The same pattern appears everywhere. Motion creates survival. Motion creates danger. The universe spins because matter inherited motion, preserved it, and amplified it through collapse. But the reason feels terrifying because spin is never merely decorative. It decides whether gas becomes a star or a disk. It decides whether dust survives long enough to become a planet. It reveals whether galaxies contain more mass than the eye can see. It turns dead stars into clocks. It lets black holes drag space around them. It stores energy that can feed radiation, jets, and collapse. The universe is full of circles because straight falls rarely last. Gravity pulls matter inward. Sideways motion keeps it from arriving cleanly. The result is a universe of curves. Orbits, disks, spirals, rings, jets, wobbles, ticks. From far away, the shapes can look graceful. From close range, grace disappears. A protoplanetary disk is a storm of impacts. An accretion disk is matter being heated before destruction. A spiral galaxy turns inside an unseen mass. A pulsar is a dead core firing beams into space. A spinning black hole drags the road beneath anything trying to pass. The universe did not spin into order because it was peaceful. It spun because a perfect collapse almost never happens. The sideways motion survived. Then gravity tightened it. Then time made it powerful. There is no need to imagine the entire universe rotating like one giant wheel. The real picture is stranger. Everywhere matter gathers, local spin appears. Clouds spin, stars spin, planets spin, galaxies spin, black holes spin. Some rotations are slow enough to feel eternal. Some are fast enough to become catastrophic. Together, they form a universe where almost nothing stands still, and stability depends on motion that could become destructive if the balance shifts. That may be the reason it feels uncomfortable. The universe is spinning for a reason. Because angular momentum is hard to erase. Because collapse makes small motions grow. Because gravity rarely pulls matter into perfect stillness. Because the same laws that build structure also preserve the violence inside it. The terrifying part is not a single object. It is the pattern. The spin that gives Earth a day also belongs to the same cosmic family as the spin that powers pulsars and twists spacetime near black holes. Outro. A gentle sunrise and a relativistic disk share the same mathematical ancestry. L equals I times omega. 1/2 I omega squared. Small symbols, mass, shape, spin, energy. Then the universe fills those symbols with planets, stars, corpses, and monsters. No equation looks frightening until matter obeys it. Somewhere, a young star is forming inside a rotating cloud. Somewhere else, a black hole is feeding from a rotating disk. In another region, a pulsar sweeps its beam through darkness hundreds of times each second. Farther out, a galaxy turns inside a halo no telescope can directly see. And here, Earth rotates quietly beneath living things that can mistake steadiness for safety. The sky looks still because the motion is too vast to feel. The stars look calm because distance hides speed. The darkness looks empty because the heaviest things do not need to shine. But the universe is moving, turning, falling without arriving, spinning without rest. The reason is written into the way matter collapses. Fear is written into what rotation becomes when gravity has enough mass, enough time, and no mercy. The universe is not balanced because it is safe. It is balanced because every piece of it is still moving. Click here for more dreadful space explorations.